Hey everyone, I am Miss Hu, your physics teacher. In this video, we are going to go through question 4 of this paper, and this question is from Unit 1, Motion, Forces and Energy. This question focuses on the center of gravity as well as the concept of moment. So in this video, we're going to go through the answers to the question, including how to get the answers, especially for the calculations, and we're going to do an immediate comparison against a mark scheme so that you can see what actually needs to be written so that you know what to write when it comes to your paper to score the highest marks that you can get. So I've split the screen with the question paper on top and the answer at the bottom, but I've blurred the mark scheme for now, so we'll only refer to the mark scheme when it comes to checking the answers. Question 4. A radio transmitter is a very tall, thin cylinder. It is prevented from falling over by wires which have one end fixed to the transmitter and the other end fixed to the ground. The ends of the wires in the ground are a long distance from the transmitter. Figure 4.1 shows a transmitter and two of the wires. So let's have a look at the diagram. I'm just going to click so that you can see where the transmitter is. Here's the transmitter, and these are the two wires that the question is referring to. Question A. The center of gravity G is shown on figure 4.1. Let's look at the diagram again. The question has labeled G, which is the center of gravity here. Number 1. State what is meant by center of gravity. So this is a recall question where you need to be able to recall the definition of center of gravity. So the center of gravity is the point where all the weight of the object appear to act. And that's what we can write. I'm going to write that out. This is the point where all the weight seems to act. Oh, my typing. Okay, here we go. So let's have a quick comparison against the answer scheme. And as you can see, you can actually use the term point or place or position. Any one of this is accepted because as long as you're referring to the location where the weight seems to act. So that's the focus of this particular question. Yay, we've got 1 mark. Now let's move on to the next question. Explain why the radio transmitter without the wires is a very unstable structure. Before we jump into the answer, first of all, let's examine what's really going on in the diagram. So the question asks us about the radio transmitter without the wires. So looking at the diagram, we have the transmitter here. These are the two wires which have been set up, and the question's asking, what if we don't have the wires? So this is a very logical question which you should be able to figure out the answer based even on real-life observation. If you don't have the wire here, obviously the transmitter will not be very stable. It will tend to fall over, correct? Now we need to explain the situation based on the physics concept that we have learned. So when we talk about a transmitter being unstable, that means it's going to fall over. Or in other words, it's going to topple over. Now, what could make the transmitter topple over? Obviously, the weight of the transmitter. So if the transmitter does not have the two wires in place, any slight shift in terms of the transmitter will cause the transmitter to fall down. And that's because of the center of gravity. The weight will pull the transmitter down towards the ground. And when we look at how the transmitter falls down, it seems to rotate where the base is the pivot point. So this is all about moment. That means that without the wires here, any slight shift in the top part of the transmitter would cause the transmitter to topple over because there is moment caused by the weight of the transmitter. So that's what we can write in our answer. In fact, if you look at the mark scheme, there are two possible answers. You can either say that a small tilt or rotation would make G no longer above the base vertically. Because the only way for the transmitter to remain stable is when G is directly above the base. So there will be no toppling over. Alternatively, you can also write about moment, where a small tilt or rotation will produce moment that topples the transmitter. You don't have to write both. This is a 1-mark question, so you just need to write only one. So you either write the first one or you can write the second one. The key thing here is to understand what's going on. So it's all about the toppling of the transmitter due to the moment caused if there's a slight shift in terms of the transmitter where it's no longer upright. So let's look at B. Wire W is under tension and it exerts a force T on the transmitter. On figure 4.1, mark an arrow to show the force T exerted by wire W on the transmitter. So let's look at figure 4.1. As you can see, there is no force T there because you need to draw the arrow of force T. So to answer this question, you need to establish the direction in which this force is acting. We need to draw the force along wire W. Is the force going to act upwards or downwards? So think logically. So if you can't figure out the answer, try to think about it in real life. If you set up an upright pole like this transmitter, and if you set up a string or a wire from the pole down to the ground like this, if there's too much force along the wire, obviously the transmitter is going to fall down towards the ground in the direction where the wire or the string is pulling, correct? And that tells us there is a force pulling the wire downwards. So how to draw the force direction? Just draw an arrow on the wire like this. And don't forget to label. If you only draw the arrow without the label, the examiner might not know what your answer is. They're like, what is this? Is that some sketch that the student drew by mistake? Remember the question asked us to mark an arrow to show force T. So label the force T right next to the arrow that you have drawn. Let's check the answer. As you can see, it says arrowhead marked along W towards ground. And that is our 1 mark. Let's look at number 2. The force T produces a moment on the transmitter about its base. Describe how the moment produced by T is calculated and indicate on figure 4.1 what is meant by any other terms in the description. So there is 2 parts to this question. First of all, we need to describe how the moment is calculated, and then we need to indicate on figure 4.1. That means by drawing arrows or labels to show how the terms are obtained from the diagram. So first of all, how do we describe the moment produced by T? So to get moment, what we can do is we calculate the value by taking the force times the perpendicular distance from the pivot. So that's what we're going to write, where the moment is the force, or even if you wrote T, it would be acceptable because that's how it's labeled in the question. And you're going to multiply this force with the perpendicular distance of the force from the pivot. Now, if you wrote base, it's also accepted because the base is the pivot in this question. So you can either write pivot or base. I'm going to leave it as pivot here because sometimes writing it in general is a more secure way to get the answer. Is in case you mistaken the base as pivot when it's actually not. So this is the first part of the answer. So the second part is to indicate what is meant by any other terms in the description. So the description is actually this equation. The only things we need to label in this equation are the contributors to the equation, not the answer. Obviously, we can't label moment because we can't get moment directly from the diagram, but we can get the force as well as the perpendicular distance. So if we look at the diagram, we already have force T. So the other thing that we need to label is the perpendicular distance of the force from the base, which is the pivot. So remember, you need to label the perpendicular distance. Now, if you did this where you took the base from T like this and you labeled, oh, this is the distance, this is incorrect. So I'm just going to mark an X here to show you this is wrong. Why? Because you need to measure the perpendicular distance of t from the base. As you can see, this is not the perpendicular distance. You cannot say, oh, this is a perpendicular distance because this is perpendicular from the transmitter to the ground, nothing to do with force T. So this is one common mistake that a lot of students make. I'm going to erase this. Then the question, of course, becomes, then how do we get the perpendicular distance? So to get the perpendicular distance, you need to find the line which links the base to the force at a right angle. So place your ruler in such a way that you can get 90-degree angle from T to the base. And as you can see, this is how we should be measuring the distance, because here is our right angle. So this is the distance. I'm going to label this as D, and I'm going to add D in our calculations here so that it's easy for the examiner to find where D is based on our labels. Now let's check the answer scheme. And as you can see, 3 marks are given if you did both, where you indicated the moment as well as the correct indication. In the answer scheme, you can see they labeled it as F times D, and they said correct indication of F and D. So it's okay to use symbols in your answer as long as you use the same symbols in your label in the diagram. Make it easy so that the examiner can find exactly what you are referring to in the diagram. So if we did this correctly, we would, of course, get our full 3 marks. So we have this, and we also have this. Ta-da! So if you're looking at the mark scheme and you're wondering, what are the additional 2 at the bottom? So these 2 are optional marks if the student did not get the full 3 marks as indicated on the top, as indicated by A3. So if the student's answer is incomplete and didn't get 3 marks, if the student has written this at least a force times distance, they will get 1 mark. And if the student wrote force times perpendicular distance, they can get another mark. So that's what the mark scheme means in this case. Let's go on to C. The radio transmitter uses radio waves to transmit radio and television programs. State one other use of radio waves. There are many uses of radio waves, and because this is a recall question, it's only worth 1 mark. So any appropriate and correct use of radio waves can be written here, and if it's correct, of course, you're going to get your 1 mark. So radio waves could be used for broadcasting, could also be used for telecommunications. You don't have to write more than 1. I'm just writing multiple answers here just to show you that there's actually more than 1 possible answer. If you're in doubt and you're not sure whether your answers are correct, it's okay to write more than 1 answer. As long as you have 1 correct answer, you will still get your 1 mark. So I'm just going to write a few more here just as options. So these are some of the uses of radio waves. If we just have a quick check against the mark scheme, as you can see, a use of radio waves, they've given some examples over here. But for this particular answer, it's not limited to only what's in the mark scheme. Like I said, as long as the use that you have written is appropriate and correct, you will get your 1 mark. I'm just going to give myself the 1 mark because why not? And that's how you solve question 4. For the other questions in this question paper, do check out the playlist in the video description below. Studying!